Okay, hello and welcome. This is going to be the Unit 3 mid review, the mid unit review, and we are going to go through first 5 problems in this video, and then I'll pause the video and I'll make another one for problems 6 through 10. Okay, so let's get started. The first question here says, which of the following expressions is equivalent to f of x divided by g of x? So this is going to be when you are making a fraction out of f and g. So essentially what you want to do here is you're creating this fraction where f is dividing by g. And what I'm going to do is I'm going to start factoring the top and the bottom. So the numerator, I look to see if there is anything in common between x cubed and minus 16x. And there is an x that we can factor out of each of those. Become x squared minus 16. And the denominator is going to be 2 binomials. We're going to need to multiply. We need to multiply to negative 28. And we need to add up to negative 3. So those numbers are going to be negative 7 and 4. So we're going to make negative 7 and negative 4 in our factors. So this is almost factored, but now we need to factor x squared minus 16. And this is going to be the difference of squares. I'm noticing that x squared is a perfect square, and so is 16. So we're going to rewrite this numerator as x times x minus 4 and x plus 4. And then it's all divided by x minus 7 times x minus 4. So now that everything is factored, all the factors are linear. We're going to look for a common factor, and we see x minus 4 and x minus 4. So the final simplified version of this would be x times x plus 4 over x minus 7. So when I start to look at my answers, I'm going to see that option C is the correct response. Okay, option C is the correct response because the common factor of x minus 4 is now gone from both the numerator and the denominator. Okay, I'm going to go close my door. So we got some loud visitors in the 3rd floor hallway. So 1 second. You guys are okay, so number 2. This is another version of simplifying fractions. So when I see larger numbers like I do with 9 and 81, I'm going to try and find a common number between them, and I'm going to try and factor that out. So I'm seeing in this expression there is a 9 and an x squared. And 81 has a 9 as a part of its factors because 9 times 9 is 81. So I'm going to take out a 9, and then I'm also noticing that both of those expressions have a factor of x. So 9x is going to be our common factor, and the piece that's left over is x plus 9. So what you want to do in your head is multiply 9x times x. We do get 9x squared. 9x times 9 is 81x. So we just factored that correctly, and we've got to now factor the denominator. So now I'm going to turn my attention to the denominator, and I see that every term has an x. So I'm going to start by taking out an x. I'm technically dividing out an x there. And we have x squared plus 8x minus 9 left over on the denominator. So when you see a common factor, you can factor, right? You can cancel that out. It doesn't need to be at the end of the problem. So I'm just going to try and make my life easier by dividing out the x's now. And then my next step is going to have the 9, but you're going to notice that I'm not going to write the x because it canceled out. I'm going to now instead just write x plus 9. So same as last problem, we've got to multiply to negative 9, and we've got to add up to positive 8. So those numbers are going to be positive 9 and negative 1. When I multiply those, it's going to get me negative 9. And when I add those, it will get me positive 8. So altogether, we are going to take the x plus 9. And then we're also going to take the minus 1 and make an x minus 1. So now I'm fully factored, both numerator and denominator. And there's another factor that can come out. We can take out the x plus 9. So the final answer for this one is going to be 9 over x minus 1. And that is the final simplified form. And that's number 2. Okay, number 3. Number 3 is when we are going to have to subtract. And you may see this on your quiz. Maybe it could be an addition problem as well, but there's going to be some either adding or subtracting that needs to be done. And in order to do that, we need a common denominator. Okay, now for both of these questions, we're going to need a common denominator. So what I like to do is I like to analyze the two different denominators. And in this one, we're seeing that one of them is 5x plus 1 and the other is x minus 2. And I can't really multiply either of these to turn one into the other to make a common denominator. So instead, what I'm going to do is I'm going to write down my common denominator that I'm trying to put on each fraction. So x plus 1 is going to be the first part of our common denominator, and then x minus 2 is going to be the other part of our common denominator. So when I look at this common denominator, I'm color coding because I want you to recognize which fraction already has which piece of the denominator. So if we look at this first fraction, this one's in blue because we already have a 5x plus 1 in the denominator. But this one does not have an x minus 2 in the denominator. So I'm going to multiply those expressions together, and that will form a common denominator. Then the operation is subtraction, so I need to draw a minus sign. And then the current fraction is 3 over x minus 2. And right now, that has the red version, or the red part of our common denominator, but it does not have this blue piece. So I'm going to multiply by the blue piece, and we need 5x plus 1 over 5x plus 1. So you can see that I'm multiplying by 1 in a very weird way, because technically this equals 1 and this equals 1. And that's what allows us to multiply in such a strange thing, because we're multiplying it to the top and the bottom. So when we multiply to the numerator and the denominator, we're changing how the fraction looks, but we're not changing how the fraction is valued. So I am going to now multiply both of these new denominators into my expression. So the first side is going to be x times 5 is 5x. Negative 2 times 5 is negative 10. Now this is going to be subtracting because we have a subtraction sign. And I'm going to write it as 3 times 5x plus 1. That's all now in one common denominator of x minus 2 times 5x plus 1. And notice, I didn't start multiplying these expressions because I want the common denominator to stay factored, so I know that the common denominator is of both fractions. So my last step is going to be to simplify my numerator. I'm going to write 5x minus 10 minus 15x, and negative 3 times positive 1 is going to be a minus 3. So all of that is going to be divided by our common denominator of 5x plus 1 times x minus 2. And if we simplify, we're going to make sure that 5x minus 15x is represented by negative 10x, and then negative 10 minus another 3 is going to be negative 13. Altogether, my common denominator has stayed intact the entire time. And I'm going to go look for this. I'm going to look for this answer over here. And option D is the best answer there. Okay, option D. That does not have anything that we can factor out, so negative 10 minus 13 is a correct choice. You could probably hear that we just had a bell. It's period 5 on Friday, so we're going to keep going. I've got period 6 free today, so I'm going to keep making the videos. Okay, we've got problem number 4. Problem number 4 is also a subtraction problem. So we're going to use a very similar strategy because I look at n minus 5, and n minus 5 is nothing similar to 3n minus 8. So we're going to have to build this common denominator again, and I'm going to rewrite this first fraction all in blue to show that that one does have n minus 5. We're going to need 3n minus 8 over 3n minus 8. That's what is allowing us to do that. Is technically I'm multiplying by 1. Okay, so that whole fraction is going to be subtracted away by 6 times 3n minus 8. And what's missing from our common denominator is that we need the other piece from the fraction on the left. So you can see that I'm taking the n minus 5 and I am multiplying it by the numerator and the denominator. So when I write this next line, I'm essentially going to combine everything in the numerator and I'm going to simplify it. So to show that, I'm going to write in green. We're going to do 3n times 3, that's 9n. Negative 8 times 3 is minus 24. We're going to subtract 6 times n minus 5. And that's all over a common denominator of n minus 5 times 3n minus 8. We're not quite simplified because I see an n term, and there's going to be an n term that forms here. This is a number. It's going to have to combine with this number after I multiply by 6. So my next step is to write 9n minus 24. And now I'm going to multiply the negative 6 times n, make minus 6n, and negative 6 times negative 5. Make sure you have a plus 30 there. Okay, a lot of students are going to tell me that this 6 is positive, and they're going to multiply it by negative 5 and tell me that should be minus 30. But this negative sign, aka our minus sign, is acting like a negative multiplier. So we have distributed the numerator. I'm going to rewrite my common denominator. We've got n minus 5 times 3n minus 8. And now I'm going to make sure that 9n minus 6n is represented by only 3n. And then negative 24 plus 30 is going to give me plus 6. Common denominator is still formed. And there's a little voice inside my head that's saying, divide out the 3. And the only reason I'm doing that is because I want to list it as truly factored form, and maybe, just maybe, there's a factor that could have been canceled in the denominator. That was not the case in this problem, but you do want to factor the numerator if you can, because oftentimes there will be something to cancel. But in this example, you should have 3n plus 2 over n minus 5 times 3n minus 8. Now, in my classes, we wrote this would get full credit, but this is an even better answer. And I just got a knock on my door. So I think what we're going to do is we're going to just pause it after 4, and then I'll make another video after this. So 1 second. All right, actually, I can continue the video because the person who stopped by does not need my help. So we'll continue on to number 5. And number 5 is going to feel a little like when you find a slant asymptote. Now, my students, we're going to be doing that on Tuesday, and I believe that the slant asymptotes were being done either on Friday or Monday in the other sections. So this one can be done 2 different ways. I'm going to do it one way using methods that we've done in class, and then I know that some people have been learning synthetic division on the side, and I know some of the other sections who might listen to this video do this problem with synthetic division. So I'm going to start off, I'm going to use an area model to divide this. Okay, now an area model looks something like this. Okay, we draw a little box, and it wants to know which of the expressions is equivalent to that fraction. So see how it's dividing by x minus 2? We're actually going to divide by x minus 2. And I'm going to take the x squared minus 4x minus 3 and divide that. So we're going to start by taking this expression. I know that x squared and I know that minus 3 are a part of that polynomial. So in these examples, we don't always get a perfect remainder of 0. So we have to create the potential for a remainder over here with an extra column. So when I start filling these out, I think to myself, what would have had to multiply to turn into x squared? And x times x does make x squared. So when we start making that, what's going to happen is that you're going to realize that this is only going to be a number, and this is actually the remainder. So we're going to need one less column because this was just an x squared. Sometimes we have an x cubed and we need to make an extra, but this one's just going to have an x squared, a minus 3, and a minus 4x. So this is going to be our remainder right in here. Okay, so multiplying through, I know that x times negative 2 is going to be negative 2x. And we also know that this polynomial has minus 4x. So I need another negative 2x. And that would be x times negative 2. So when we do that, we realize that negative 2 times negative 2 is actually 4. But I know that this needs to be a negative 3. So what we're going to have to do is we're going to have to say x take away something equals negative 3. And essentially what we're doing there is we're balancing out this box. So right now, this box, it's got x squared minus 2x minus 2x. So that's x squared and negative 4x. But what we're realizing is that this box does not make a negative 3. This box is actually making a positive 4. So in order to make this negative 3 the constant of our function, we need to add in a negative 7 remainder. And now these two are adding up to negative 3. So when I know that my remainder is a negative 7, that makes this answer with a negative 7 as a remainder our final answer. Okay, so that is a very conceptual way of computing this problem, and synthetic division is a very quick way of solving this. Now, my students, I'm going to post a video on synthetic division, but I do not think we're going to have time for synthetic division. So what ended up maybe happening is that you're going to watch a video on synthetic division if you want to, but you're not required to. If you can do the problem like I just did, you don't even need to use synthetic division. But if we wanted to use synthetic division, this is how this problem would look using synthetic division for Mrs. R's classes. So what I'm going to do is, realizing that we're dividing by x minus 2, I'm going to put a positive 2 in the shelf, and then I'm going to take the coefficients of x squared, negative 4x, and negative 3. So I'm going to take a 1, a negative 4, and a negative 3. So when we divide, remember that our answer starts appearing here. So we're going to bring down the 1. 1 times 2 is 2. Add down, negative 2. 2 times negative 2 is the negative 4, meaning our remainder is negative 7. So when we got up here and we saw x minus 2, that is still the case, x minus 2, and the remainder is a negative 7 over the divisor. So answer C is the correct answer for number 5. Okay, I am going to stop the video now because I think it's probably been about 25 minutes, and I will do the second part of the video now.